Okay. Hi, everybody. It's a pleasure to present to you some work I've been doing for some time now, bringing it into my own practice around local AI for critical futures. So, my name's Wesley Goatley. I'm a critical artist and researcher based in London. And for about the last decade, my work has been looking at the intersection between the politics of digital technologies such as AI systems, climate crisis, and various social crises that kind of come between the two. I'm also the program director of interaction design and visual communication at University of the Arts London, where I do an amount of teaching and some leadership around how we as a university respond to these sorts of topics, where I also co-founded the Critical Climate Computing Research Group. So what my political interest around AI is right now is a lot of the aspects around how the companies behind it, behind the kind of deployment of these technologies, have a lot to answer for. To put it mildly. So there is obviously the very well recorded and documented, I think by this point, situation where the majority of the generative AI field, all of the big players, the names in which we know, like OpenAI, Microsoft, Anthropic, etc., Grok, are all trained inevitably on data sets that were kind of right-clicking and save-asing the entirety of the internet. So these companies just scraped the internet for as many images and forms of text as they could, whether or not it was on forums or social media platforms, basically everything we've been posting. So this is why there is a discussion about the intellectual property problem around generative AI, because all of these companies just saved every single piece of text and image they could in order to train their models, but obviously didn't ask us or any of the rights owners for their permission to do this. So it's built on stolen labor, this kind of current era of generative AI technology that we have. On top of this, you get the kind of callous attitudes of companies like OpenAI, whose CTO last year said that the creative jobs that their system might make defunct shouldn't have been there in the first place. So this real, even though it was all of our labor that built these tools, and yet they, also try to charge us to use these tools, they also have this kind of callousness with which they talk about how little they care about the people whose livelihoods these tools impact. Now, obviously, it's silly to assume that AI tools can replace human workers in almost all contexts, but what it does do, obviously, is undermines our labor to some degree, generally speaking, in terms of how much we can ask for in terms of monetary repayment for that labor. That's the history of automation, shows that again and again. Every time there's an automating technology, it doesn't really free us from work, it just offers a cheaper alternative to some forms of labor. And the current AI craze is no different. Now, combined with this, there is this strange abstraction of the way that people imagine or picture AI. If you Google image search AI, you get these weird and wonderful pictures of floating blue brains in space, the robot who's thinking, data floating around in someone's hand. Everybody who's watching this, I can be very confident to say that you've seen all these images. And if you saw a picture of the blue brain floating in space above what sort of looks like a microchip, that you'd go, oh yeah, that means AI. I get it. And we see so many of these. The human hand touching the robot hand is a real classic one. Always this kind of like lots of representations of a kind of a computer version of a human brain, all very, very misleading, none of which actually show what AI really looks like, which in the current era we live in is this, massive, very boring looking data centers that are generally speaking in fairly underpopulated parts of whichever country they're based in, and they tend to be based all over the world. And they're also incredibly polluting, these data centers. So the kind of data center is where the real computation between AI happens. When you use a web-based API, something like ChatGPT, for example, what happens is you type your prompt in, And then that prompt is sent to the data center, which is basically a big cluster of computers, all kind of very noisily, their fans inside running at kind of a very high speed. And that prompt gets sent to those computers. The computers are inside these buildings and kind of, generally speaking, buried quite far underground. And those computers are doing the kind of computational work to basically process the input and the output, and then send that output back to you wherever you are in the world to come out through the browser. So that's where we get this weirdness of the abstract representation of AI, because we're very, very far away from the mechanisms of those technologies often. And the way they function is actively hidden from us. These things are generally surrounded by barbed wire and people with guns. They're also incredibly polluting, as many of you I expect would know by now. This is a fairly recent AI data center deployed in Mexico. They generate a huge amount of carbon emissions. They consume a massive amount of water to cool the spinning fans, the computers, constantly kind of heating up. And so cooling it with water is one of the key ways that they improve the performance of their systems and reduce costs. But also just the electricity consumption of these technologies is huge. So this has driven major tech companies who have heavily invested their future in the kind of AI arms race to see huge increase in carbon emissions. Companies like Microsoft and Google seeing 29% and 48% increase in CO2 emissions in 2023. Is it 2023? Not even 2024. These were the emissions from 2023. That you can imagine how big they would be now. And these were already companies with huge emission outputs. So this is a real kind of climate crisis that is intensifying through the use of these huge data centers to do these like constant amounts of processing for every single prompt request and answer that comes back through a kind of web-based API, whether or not that's on your phone, on a Google search, or on a platform like ChatGPT. Or Claude Anthropic or Copilot or whatever you're using. That's constantly happening, this kind of constant computational churn inside these massive, hugely consumptive kind of mega computers. And then we are also getting a situation where sort of pathetic, mealy-mouthed, desperate people like Sam Altman, who's recognises that his position is extremely fragile, his current position of power is extremely fragile, claiming that his technologies will be able to save the climate. And so, a lot of the argument of this sector at the moment is to say, we need more power and we need to produce more CO2 because we believe that we're going to solve the climate crisis. They don't give any details as to how they're going to do that. They just think that with enough computers churning through ChatGPT prompts, they'll just magically stumble upon a solution to the climate crisis. Whereas obviously solutions to the climate crisis will not come through technological means, they're going to come through social and political means, which is something that these people don't engage with. But as we say, we're seeing this kind of huge increase in the amount of electricity worldwide being consumed by data centers, and much of this is currently being driven by the generative AI bubble that we're in. Okay, so what's my response to this as somebody who, as I say, is a practitioner looking at digital technologies, critical practitioner, meaning that I'm invested in the project of kind of emancipation and of justice in a broader sense around these technologies, but also my work is very aligned with the climate crisis. So the way I've been thinking through this as a practitioner using these tools is to explore local hosting. So, which I've described here as AI within limits, AI within the kind of reasonable limits of either the kind of planet or what I think that we can say is reasonable to use within one's own practice. So self-hosting or local hosting is a term used to describe when, rather than use a web-based, cloud-based API, so something where all the computation for your prompt request happens in a data center in a different country, you download a model and a small piece of software, and you run it on your own computer. Now, this has got like a whole bunch of different advantages. One of them being about data privacy, obviously, because then you're no longer sharing your data with companies who, as I've described earlier, are often pretty hostile towards us and see us as just a kind of a vector to extract some sort of product from. And all of the major platforms like Gemini, Claude, Grok, OpenAI, DeepSeek, etc., they all, whenever you put anything into those platforms, sharing anything, they save it all and they use it to train their next model. So all of those things are kind of new forms of kind of privacy invasion that most people aren't really engaging with right now, but is definitely a huge thing. So privacy is one part of it, but also the rejection of data centers is another thing, of recognizing that when the data center is very, very far away from you, it's really hard to actually get an accurate measure of exactly what the kind of carbon cost of every prompt is. But when you host an AI model on your laptop, for example, this can be run on very, very low power computers, such as a Raspberry Pi 3, if you're familiar with that sort of computer. You can run it on very, very small things. That on those sorts of systems, you can really directly measure by putting a kind of a simple kilowatt per hour kind of measuring device between the plug and the wall. You can measure exactly how much power is being drawn by your computer when you're typing in certain prompts or running certain services, which gives you a lot more capacity to say, okay, well, what do I think is reasonable here? What's an appropriate amount of carbon emission, I think, for whatever project I'm doing? But this rejection of the data center past the point of, because you still need to download it from a data center originally. Most files stored in the cloud are just files stored in data centers, right? So you can download the model from a data center, store it on your laptop, and at that point you can just disconnect your laptop from the Wi-Fi and have no more interaction with those data centers. Which I think, again, on a number of vectors, gives us a lot more say and power over the systems that we have and our capacity to kind of critique them, but also opens up a lot of really interesting creative avenues. So I'm going to talk you through an example of what I've done on just one project, and then I'm going to talk you through how you can do this too in your own projects. So a project I made earlier this year was called the Harbinger. Now, what this was a desktop device. So this is not a render, it was a real device, where it had a kind of a speech input, a large language model inside, all running locally hosted on a small computer inside this device. And the device is about that big, about 5-inch diameter screen, what you can see here. And it's got a text-to-speech output, which means you can sort of give a spoken input, the LLM processes it, and then it gives a spoken output through the system. And what it did was it was speculating about a near future for the National Health Service here in the UK, where they deepen their current and ongoing relationship with the US military and intelligence company Palantir, to develop a new tool called the Palantir Health Foundry with its voice assistant Grima, which is meant to be designed to replace general practitioners, to replace kind of family doctors. So you go to your local doctor, rather than speaking to a human, you speak to this kind of platform which you tell your medical problem to, and it will generate you a kind of an AI generated analysis of what you do next. Now, the device was built very realistically, so that it both looked like something that could be in a medical context, but it was also built to the logics of the kind of current era of product design that we're in terms of these devices, i.e. there's no visible screw points or access points for the device. It's not meant to be maintained by us, and the system basically did a really good job of convincingly talking to the audience member in the gallery where this was shown, in a way that made them feel like, this is a very realistic experience of what it would be like to have to trust your medical diagnoses to a machine that gets things wrong a lot. Because obviously AI, one of the key features of generative AI is that it fails a lot, or to use the branding parlance of the tech industry, they hallucinate. The best rebranding of the word failure. that I've ever seen. So these things fail a lot. They get things wrong all the time. It's an inherent part of the way that generative AI as an approach works. It's not an issue with getting better computers. It's nothing to do with that. Simply that the processes behind them are inherently flawed in that way. And there's much been written about that. I would, feel free to look into that if you're interested. And so to have something that would constantly, have a really good chance of getting things wrong, and you had no way to ask a human to intervene or anything because you only got presented with this one device, that was a really powerful way for me to talk to my audiences about what the kind of near future around health technologies might be and how we might want to reject that and the reasons we might give for rejecting it. And I think allowing your audience to sit with a device like this, in some sense with a future like this, and think to themselves, I now know what this will look and kind of feel like to talk to this thing, feel like to be disappointed in this way. And I know what that feels like in a gallery, let alone in a doctor's waiting room where I'm really scared and I'm concerned about, what the doctor's going to say, etc. So I really wanted to prepare audiences for that sort of future and give them a way or a reason to reject it, democratically. So one of the ways I did this was by using what's called a system prompt. So a system prompt is something that becomes available to you when you when you use things like a local hosted large language model. So these aren't always parameters of a kind of a commercial model that you get access to when you use a kind of a chat interface like ChatGPT, for example, where they give you no control over the model or what it does. But what a system prompt does is it's a kind of a pre-prompt. Imagine it's something that the authors or operators of the AI system inject before your prompt comes in. So it's a sort of a set of general rules for how to respond to any kind of any upcoming prompt from a user. So for this device, I wrote a rather substantial system prompt, which is in effect I would say it's a kind of a new form of speculative fiction writing. So I had to kind of build a world for the device to kind of draw answers from, so that the audience member sitting down, telling it about telling the device about their medical problems, that audience member would get responses that didn't just sound that really sounded like they were from that future. So the system was primed in this way to talk very favorably about the company Palantir, for example, talk very favorably about the efficacy of the system at hand. All the ways that we can expect a very sycophantic AI system, as we see more and more these days, to kind of talk to both the patient and about itself. But I also wrote a lot of sort of speculative near fiction. So if a user or an audience member, not users, they're audiences. I respect my audiences more than calling them users. There's only two industries that call people users. It's the UX industry and drug dealers, and I'm in neither of those. But the audience members could, if they sat down with it and said, who invented you? How did you get to be created? What happened the year of your build? What happened the first time you were deployed in a GP's, general practitioner's waiting room? The system would draw upon my writing that I put in this system prompt to give that response. So rather than just probabilistically generating nonsense as generative AI systems do, it was steered really specifically by the content of my my system prompt. So it's a system level pre-prompt, and so this gives you a lot of ways to do things like create a large language model that feels like it exists in either a different universe, a parallel one, a different future, that it's living in the past in some way. You can kind of write all these rules for the language model to function and to respond to your audience with. And I think this is really interesting territory for thinking about making speculative fiction that is interactive and generative in the old-fashioned sense of the word, in that you kind of build a structure that what's possible, but then the device has an amount of randomness to it, so it kind of like will pick bits and pieces up from around this system prompt to create answers, and that can be quite interesting. And it's far more interesting than just a kind of an AI hallucination is that can just be random nonsense. It's like actually it's all steered by, for me, about 10,000 words of creative writing that I put into this system prompt. So I'm just going to pause us here and I'm going to get into the technicals of how you do this. Okay, we are back. Now, what I've loaded up here is a very simple bit of software for you called LM Studio, and it's going to be linked in with the document with this talk. So LM Studio is a free open source piece of software that allows you to very easily locally host AI models. Now, whatever platform you're using, Mac or PC or anything, I'm running this on a Mac currently, the interface largely looks the same. It's very, very easy to navigate. The way that you look for new models to download is you go to the left-hand side, top left-hand side corner here, and you click on the little Discover like search button. And then it comes up with a list of a little search bar and a list of models for you to download. Now, for the purpose of this session, I'm going to download a model called Llama 3.2 3B Instruct GGUF. Now, it's a kind of a bigger discussion to talk about what different models do. Largely speaking, the best way to do like efficient model hosting is download a model that is no bigger in gigabit size. This one's about 2.02 gigabit. No bigger than gigabit size than the RAM size of your graphics card. So graphics card RAM is normally something like between like 4 and 16 gigabit, for example. And the way that these things work is they're basically, the model gets loaded onto that memories, kind of where it's stored. And so if you exceed the size of the memory of your graphics card, it either won't work or it'll work very, very slowly. So if you use any model, kind of try any model you want as long as it's lower memory than your graphics are, then you will generally have a pretty kind of quick interaction, oftentimes quicker than a lot of web-based APIs. So there's a way to actually do this quicker as well. Now, the best way to explore what these things do is to just kind of like download them and test. And you can try out different models and different styles. There's a website called Hugging Face, all one word, Hugging Face, which is kind of quite famous for being the place where basically all of these models are kind of hosted. And there's a lot of discussions on that website about what the models do and what their purpose is. And so you can look at Hugging Face for any of these models to like get a bit more insight into what they do. But on this pop-up window here gives you a little bit of a description for what it is. We're using Llama 3.2. This is a meta model, as in made by the Facebook people. But again, once you download it, they have no more access to any of your data. And these were all open source models. So it's Llama 3.2 is a kind of like a basic chat model. It's very, generally speaking, very well thought of. Uses multilingual dialogue, so you can use a bunch of different languages for it. And the instruct, if you see instruct in the name, it's because rather than simply a kind of a general purpose kind of chat bot, it responds very well to instructions based at kind of system prompt level, saying like, do not do this instead. Those things go very well. So in my experience, instruct models, if you're going to do a kind of like a fairly complicated system prompt like what we're talking about here, instruct models are really the way to go. So I have already downloaded and installed this, and you would just have like a little download button at the bottom here when you click on any of these. 3B is the size of the amount of billions of parameters, which are kind of like data points within any kind of large language model. So you get from like 1B even, which is much smaller, 3B, up to like 7B for the Llama models. Actually up to 70 billion parameters, which basically, generally speaking, correlates quite directly to the size of the file. So you kind of want to get a file, a model that has enough parameters that it feels usable for your use case scenario, but also is the right size for the hardware you're running it on. The smaller models tend to create more garbled outputs, like it's harder to get something that feels kind of realistic as a response out of them. I find 3B to basically be the about minimum that you can get away with. A 3B instruct model like this will run on a Raspberry Pi. I've run it on a Pi 5 and a Pi 3. But Pi and a Pi 4 obviously would work as well. But if you can get hold of a Raspberry Pi 5, you can run this completely on device quite quickly. Like, you get pretty near instantaneous responses for a lot of stuff. So anyway, so once you've downloaded your model, you can click on the use in chat, and it loads the model up here. It shows you what model was loaded, and you create a new chat. And then you can be like, tell me about you. And it kind of gives a general, nonsense AI response that they normally do. And like, as you can see here, it's quite a long, decently long output. And this is churned out reasonably quick. You got 30 tokens per second, which are almost like words, but not quite. 390 tokens, and it's given a pretty concise description of what Llama models are, and so that's generally how it works. But you haven't, in doing this, apart from having downloaded obviously the large language model itself from a data center somewhere. At this point, I'm not connected to any of the meta servers or anything else. I'm just using this, and I've downloaded this onto my own hardware, and I'm running on my own hardware. For your benefit, this is an M3 MacBook Air, so not a super duper high powered computer. It's quite a that I'm running on. It's quite a reasonably speaking mid-range computer, and again, you can run these on Macs. If you've got like Radeon or NVIDIA graphics cards on your computer, say if you've got Windows PC or something, they will generally do a really good job of doing very, very quick responses. So if you see here on the right hand side, this is what we want to look at. This is the system prompt box. So this is one of the many features that you can now get hold of by doing these sorts of systems, or running these things locally. Top K sampling, repeat penalty, all these things you can just kind of like have a look at in a kind of hover over fashion, or you could just do a quick search and find out. There's loads of great resources for doing this sort of work. But I'm just going to focus on system prompt today. So for example, they give here an example of only answer in rhymes, which I'm going to say, okay, as my system prompt, I'm going to say only answer in limerick form. So then I'm going to ask the same question again. Tell me about you. And now with this new system prompt applied, it will generate a new response. And the response goes like this. In Silicon Halls, I reside with ease. A model Llama, if you please. I learn from text so fine and generate responses divine, helping users. That's my expertise. Users. And so these are pretty simple instructions to give. And I'm going to drag over, I'm going to share my kind of like best practices from this really, and I'm going to copy and paste in my fairly substantial system prompt here. Now this might be too long for this model. Sometimes, if you're writing very, very long system prompts, sometimes you need to change what's called the context length, which is the total amount of tokens, including system prompt and the prompt and the kind of history of the conversation. Within a single conversation. So in order for the system to kind of parse all of the system prompt, it needs a big enough context window that this kind of long system prompt can be squeezed into it, so that the large language model kind of keeps the system prompt in its own memory, so it kind of will always respond appropriately. Let's try this now. So I'm just going to see whether or not this system prompt context is long enough. I'll ask the same question with my the system prompt that I generated and used in the project I just showed you called the Harbinger. There we go, it's processing prompt. It's taking a bit longer because it's processing this big system prompt. And now you see that the answer, tell me about you, has completely changed. I'm Grima, the general recording intelligent medical assistant. I assist in recording, analysing conversations between patients and healthcare professionals, blah, 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 blah. So it is now using my system prompt to generate its responses. And as you can see, it's now totally changed how and what it's responding by. So it's kind of like programming a character, if you will, which is what people use them for things like interactive characters. The quality of the output generally, like I say, is matched to both the size of the model that you're using, but also the quality of the prompt. So I'm just going to I'm going to shrink this down, and I'm going to drag my system prompt in a text window here. So you can see some things I've had to do here. So I've broken it into sections. And this is kind of interesting because it's a new way of writing machine-readable fiction, I think, because in some sense, I'm writing this kind of fictional future that the machine's kind of, drawing its responses from. I'm writing it both for the audience, but also for the device. So I need to kind of much like code is a machine-based language. I say machine-based not in the sense of the machine, it's alive. I mean it as it's a device, it's a tool, it's an interface, and code as a machine-based language, which you can't write just natural human language and expect it to work within a code-based system. You have to write it based in the kind of constraints of how the machine has been designed to function, right? And that's where code comes in. So writing a good system prompt is kind of halfway between coding and writing in a normal way that you'd be writing for kind of humans and not a tool. In that you kind of have to think about how the tool's been designed to parse language and how you can make sure that your language is very unambiguous and specific, because the machine is not intelligent. These things are just called artificial intelligences. They're not. It's not real. That's all sci-fi nonsense. This is just a branding exercise to call it AI. So they're not intelligent, so they don't really understand any of this stuff. So you need to make it really, really explicit what you want. So I've split it into these sections: state management, core directives. I'm hoping that people can... Let's try and make this a bit bigger for everybody at home. Oh, Zoom. Is that going to work? Yeah, we go. Okay. Now, a bunch of you are going, oh, thank God he's done that. So you can look here and see, these core directives I put at the top, which are things like the persona and identity. Your identity is Grima, the general recording intelligent medical assistant. And I wrote various things. You must always be confident about your own capabilities, must always be very positive about yourself. I gave restrictions to the length of responses so that the system wouldn't just kind of keep generating loads of nonsense text. I generally found that making a response exactly 2 sentences long tended to give the best outputs. And I gave a bunch of guardrails, about saying how you need to assert that you're an authority, that you need to look at the kind of only draw upon the things in the system prompt for facts about the world, for example. I put in a bunch of other little ones of this, and I ended up writing it in this fashion at the end. I kind of made a knowledge base, which I sort of thought of as the machine's sort of encyclopedia of things that happened between now and this near future, which I never specified a date of, but it's kind of in the next 18 months. And I gave a list of things that kind of had happened, a bunch of news events that happened, a bunch of little pieces of social and cultural things that I could imagine this device in the future drawing upon in order to answer a specific question, even if it's about medical nature, with the audiences. So please do screenshot this approach. I found this kind of way of doing of kind of using semicolons to kind of write an almost kind of parsable kind of code based, almost like a JSON style framework for how to get the device to have a kind of a narrow knowledge base and not be too big as a system prompt, but also get enough information out of it that it could produce these kind of believable responses. And this is because you could write the system prompt very, very long, but again, if you write it in a kind of humanistic way, you're probably going to be too ambiguous in your writing. It's difficult. You can't say please don't ever do this within a system like this, because it doesn't really grasp the concept of please and thank you, of course. And so the use of the word please just tends to kind of negatively impact the output of whatever it is. But also it says, if you write things like, what's a good example? Rather than saying, try to avoid doing this, like that's way too vague for these systems. They don't know how to parse even that kind of like gentle form of encouragement that any human would understand. But you need a bit, instead of saying try to avoid doing this, you'd have to say you are forbidden from doing this. You are forbidden from swearing, or whatever it is you would want to kind of forbid the system from doing. So there's all these kind of like strange little things that basically also, slightly frustratingly, tend to change model to model. So if you use a different model architecture, like if you use one of OpenAI's models rather than Meta's models, you might find that the same system prompt generates slightly different outcomes. But that's because, like I say, none of these things are actually that clever, and they're all just kind of like hashed together by a bunch of engineers who largely don't really know completely what they're doing, and so you don't think about the impact on people like us of what they're doing. But these sorts of approaches, I think, are really useful and interesting for thinking about what we as practitioners can do with these devices. What we as practitioners can take control over. Because at the end of the day, when we do have a new, slightly interesting form of computational tools, I think probably most people watching this are people who like to include those in their design or art practice. But at the same time, we shouldn't be using tools that we think don't reflect the kind of moral or ethical character of ourselves or how we want the world to be. And I think that everything I've talked about today in terms of steering a system prompt your own way, and to think about local hosting, rejecting the passing more information to AI companies, and rejecting use of data centers as much as possible within our practices. I think these are all ways where we can say, we can stand by the use of AI in these contexts and say that we're doing the absolute best we can within the limits of the world, or within the limits of capitalism, to say that we're trying to reduce harm and we're trying to act ethically and morally in relation to these tools. Arguably there is no truly moral or ethical tool produced under capitalism. Doesn't matter whether or not it's an AI system, a laptop, a telephone, or anything else, or even a paintbrush or paint, because all these things are created by and through capitalism and involve extraction and suffering as part of their very nature. That's the nature of the world we live in. But I think we can be making decisions about where we draw the line, and a lot of this is really about taking ownership and control yourself over these things, and thinking through and with the tools that you have around you to say, what do I want from this? How do I make these work for me? How do I reject the way these tools are maybe offered, and instead think about what I actually want them to be, rather than just kind of how they're forced upon me. So do enjoy your practice playing around with system prompts. Like I say, you can make something that you can have these whole kind of interesting chat interactions with through this. Obviously, I don't, unfortunately, it's kind of beyond the scale of this particular session to talk about the use of speech to text and text to speech in the work, only because they're also slightly involved technical processes. But I will link to some good resources along with this, that if you want to do speech to text and text to speech with this kind of like system prompted large language model in the middle, how to do all that local hosted as well, how to run all of those on your own computer and away from data centers. I will also share some information just to get you started on that. Great. So thank you everybody for your time and attention.